So, let us start with what is natural language processing. There will be a huge one particular course, 12 weeks course of introduction to natural language processing itself. So, I will try to introduce a few basic concepts needed to create a automated essay grading system. Okay, that is what we will talk in next video. I will introduce the concept needed for understanding how to grade a system to automatically grade a essay. So, let us talk about the first two concepts like lemma and stem. Okay. Lemma is if we are given a word, we need to identify the root form or basic form. Okay. So, grouping the inflected form of words, for example, eating, ate, eat. So, eating, ate, past tense or eats, all this forms to a root word called eat. It is a verb called eat. The verb eat has been used as a ate, eat, eating, eats, all these things like talking, talk, talks, talk, everything is a root word like talk, right. So, this is a lemma. So, you have to find the root word based on the group those words based on that all the inflated form of these words is grouped into one particular form, that is a lemma form. Lemma is in English it is easy because the dictionary is there, a lot of people worked on that, we have all the forms of words extensions, words inflated forms available. So, we have a huge dictionary. So, whenever the words comes you just use the dictionary to find the root word and copy and paste it. So, system is well developed to do this. The simple thing in lemma is we might lose the meaning, right. So, we might lose the meaning of some words. So, not to do that they use some other called stemming. Stemming is very simple rules, there are a set of logical rules applied. The rules like remove ing, remove ed, or for example remove ing, remove ed, remove s or something like that. So, ate will be ate only, ate will not be converted to eat. Okay. Eat and ing is removed, eat, eat, ate, talk, 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 talk. Okay, it is all there. So, remove ing, ed, ly if the word ends with these suffixes, that will be stemming. So, you will be like take the stem of this, not the extra suffixes, you will be removing it. That is the 1000 feet view of what is lemma and stemming. I am not talking about any mathematical forms or the algorithm behind it, but that is not needed. If you want to know more about it, if you find interesting this particular week's video, I request you to go and check the video called Natural Language Processing course by Professor Dan Jolafsky in YouTube. Okay, it is all available freely. If you like the course, you can also just in a Coursera. But they explain completely the natural language processing introductions, how these words are extracted and what is information extractions, everything will be discussed in that particular course. It is an interesting course, check that out. So, since you saw what is lemma and stem in a basic form, I just want you to give a small activity. Consider a sentence, walking is good for health, but jogging is better than walking. Can you create a lemmatized form of this sentence, also stemmed sentences from this sentence, stemmed words from the sentences. So, pause this video, write down your answers, then resume the video to continue. So, lemmatized form is it is simple, right. We know lemma is root form. So, walking, the root form is walk, S is actually root form is B, okay, B, good for health, okay, but jogging is gone, jog, B is can be better is actually a form of a good, then walk, okay, this is lemmatized form. Stemmed form is a bit different, walking, S will not be removed, it says good for health, but jog it removed the jogging, because you know jogging means there is a G, which means you have to remove not ing, also G-ing. Sometimes if you do not have that rule, it will have a jog, J-O-G-G, that is it. Is better, so that is a problem, we do not know how to remove the word, so bet, then walk. So, that is a difference between lemma and stem, but you know other concept in NLP is very famous, is called the n-gram. It is basically a unigram, bigram, trigram or n-gram. Given a word, it is very simple, it is very simple. Given a word, say I liked to drink coffee, something like that. So, if I say unigram, I want create a dictionary with all the single words in it. So, the dictionary will be unigram dictionary will be simple, unigram dictionary will be simple. I like to drink, something like that. A bigram, I want all the two words together in the dictionary, like I like is the one word, like to is the other word, to drink is the third word, third combination of the bigram in my dictionary. Drink coffee is the one. If it is trigrams, I like to drink coffee, something comes in. So, unigram, bigram is used for applications like Google. I will tell you where exactly, but let us see how this can be used. So, what is unigram bigram tells us, like given a lot of words, lot of content exists in the world, you can go and crawl automatically, call all the content in Wikipedia database available free, you can download and use it, Google News database or something like that. Can we create a dictionary of what is the combination of words occurring together? Okay, that is the idea of bigram. Trigram, it is not needed necessarily, but sometimes there is a word which is a 3 sentence, computer science and engineering. Okay. So, computer science and engineering is different, but computer science and engineering means there is a 3 words needed to get that word. It is not necessary, but let us see how it works. And there is something called n-gram, it is something is beyond trigram, like a 4-gram, or we do not know what is, I do not know what is exactly what 4-gram called. So, anything is beyond n-gram, we will call it as n-gram, 4-gram, 5-gram, 6-gram, something like that. Okay. So, in this activity, check this sentence, learners engagement in class and the interaction with peer is peer impacts the performance in the assessment. Okay, the sentence may be not correct, but consider learners engagement in the class and the interaction with peer peer impacts the performance in the assessments. Okay, some sentence like this. Can you find out the unigram, bigram, trigram of this, not n-gram? Well, if you want to do it, just go for 4-gram, but not beyond that. Can you find this unigram, bigram, trigram for this sentence? So, after you do it, please resume the video to continue. So, the unigram will be learners engagement class, I remove the n because okay, and their interaction with peer impact, all these things will be the unigram. Bigram will be learners engagement in class, class and there, okay, everything will be a bigram. So, trigram will be learners engagement in engagement in class and class and so we are actually moving, okay, that is actually not shifting the windows, like sliding the window slowly. So, the window is sliding, so you can take the first 3 words, next 3 words, next 3 words, it is like that. So, trigram is there and n-gram, it is actually a 4-gram. Okay, so 4-gram dictionary can form. Why we are doing this? It is very important. I will show you why we are doing it. It is very simple. Okay, let us see. So, if you want to know what word will come next, when you ever wondered when you type in Google, you type the first word, it picks up and shows the second word. How the second word automatically appears? Okay, in Google search engine is not just NLP, it based on the context where you are from and what is your personal profile, what kind of words you search already. There are a lot of modeling of you happening in the search engine itself, right. But the basic idea is that NLP is this. So, what is that tells you that the current word, okay, that is a Markov's assumption. Okay. I told about the hidden Markov model in last week, but that is Markov assumption is basically this. The current word depends on last word. So, I just go for the same example, I like to drink. Okay. What is the probability of like occurring if the given word is I? You type the word I. Okay. What is the probability of second word could be like? If you consider English dictionary, a lot of sentences, the second word after I will be am, okay, not like. But maybe in sentences, if you have words most of I like, I want, that can also occur. So, that might have some probability. But probability of 2 given the current word like is high, right. So, if the current word is high, what is the probability the next word will be to mostly, like to, because mostly like follows with the to, because that is how all the sentences formed in the content like newspapers, Wikipedia. So, from the content database you can construct this probability of what is this transition of the like to to. So, you remember the test transition we talked about, we can create that kind of probability, that is what exactly happening here. So, we are creating that. To drink is not possible, you know. For example, probability of drink given to is not high probability, but consider if I have a probability of the previous word is to, also the previous to previous word is like to. Okay. So, think about the sentences which has I like to go, I like to drink, I like to eat. So, now there are like to, there are only certain form of things are coming, though instead of to lot of other words possible. Now, we have like eat, drink, go, all this thing. So, these words now we can have a better probability. So, what happens is if you have more sentences given in the probability of previous sentence, if you know about history like n minus 1, n minus 2, n minus 3, you might be able to better predict it, but Markov's assumption says that it is not needed. And mostly you will able to predict all this previous sentences will be just by the previous word only. You no need to give previous word n minus 1, n minus 2, n minus 3. The Markov assumption says that there is no need to do that. Okay, it is almost equal to considering the probability of only the previous word. So, considering the probability of current word is previous word is enough to look at previous word, like it is almost equal to probability of current word given previous word n minus 1, n minus 2, n minus 3. He says that it is no need to do that. So, that is what Markov's assumption comes from. So, the current event depends mostly on the previous event, okay, that is assumption. We have seen this, you know, I talked about bigram everything in the previous slide. This is a special form of that, you know. If you done a bigram, okay, you have a dictionary of all the words occurring together. Okay. Now, you have to compute like how many words to like, to eat is coming, just you have to compute the probability. Just once you compute it, you know automatically the probability of which word will come next if the first word is to. So, what happens is when you type in a Google, so when you type the first word, it automatically picks up based on the probability of these words occurred in the content, but in Google search is different because based on the current trend, what are the people are searching in the particular contest and what is the latest news in the particular the IP address location, all those things is considered. But in general the idea is finding the probability of current word given the previous word is what used. So, let us look at one simple example to understand that in more clearly. So, Mark likes to eat meal with his family, Kyle likes to sing and eats meal with her friends, Kiran likes music. Okay. What is the probability of, currently the word is to, what the probability of the next word will be to, TO, likes to 1 times it occurs, 2 times it occurs and 3 times it occurs. Okay. There are 3 times likes and other word occurs. So, in your bigram dictionary you will have a likes to and likes music, the 3 words, okay, something like that. How many words starts with likes? 3 words, but how many words has TO in the second? 2, okay, likes to 2 times compared to total is 3. So, 2 by 3 the probability is 0.66, very simple, right. So, what happens now is when you type the word likes, it automatically suggests you the word to, okay, TO is what picks up. So, that is a basic, very basic form of what word comes next. Okay. So, hope you understand this. So, this is also kind of probability and finding the state transition things, but given a huge dictionary, lot of content, English language has a lot of content available in the internet compared to most of other languages. So, identifying this dictionary is not easy. Okay. So, you can go ahead and take all the content in Wikipedia or Google News and create a bigram. It is easy because you might your system might support. Trigram is possible, but 4-gram sometimes is needed, 4-gram also needed, because I mean that might give a better nest word. It is not easy, it needs a lot of computational power, but Google already did it. Actually they did a 4-gram database and they have it with them, but actually marker assumption says it is not required, you just use the pi-gram is enough. Okay. Okay, let us look at the other concept. How similar is two words or sentence is the next concept. So, let us see, there are two sentences, two words, let us talk with the words. Okay. Analytics and these are the words. How similar these words given to this particular thing. So, the similarity is computed by minimum edit distance. Okay. So, how much minimum edits you have to do to get this particular word to this word. So, analysis almost same, TICS is yes. So, T should be replaced with yes and C should be inserted, right. So, the two edits you have to do. So, this is a 2 edits. Lytics, the 3 edits is needed, analytics there is 1 edit is needed. Okay, let us see. How do you find this? That is a simple rule that is called, you have to apply operators like insert, delete, substitute, and that is how the similarity is identified. Insert, delete, substitute. Let us look at the example again. So, here I am inserting this word, I am replacing this word, substituting yes with a T, okay, that is called substitute, and I am inserting the word C. So, I did one substitute, one insert. So, there are 2 operations needed. So, 2 minimum edit distance. Here lytics is there. So, I might need to insert 3 words. So, insert 3 actions, and here only 1 word is missing. So, I am inserting only 1 word, but how easy or how tough to identify this is not easy, you know. It is like I need to understand lytics is actually occurring in the last 6 words, not in the first 3 words or something like that. So, which means there should be a big matrix comparing each and everything where it is matching. It's kind of it looks complex, but if you have proper algorithm, it's not that much complex, it's easy to do it. So, that is how the minimum edit distance is computed. So, how similar 2 words? It is basically based on the missing words, all this. This is very useful in bioinformatics. There are a lot of work on this particular, exactly using the minimum edit distance. A lot of work has been going on, and there is innovation happened in that field. Okay. If you are interested, go and check minimum edit distance and bioinformatics, you might find the answer. So, have you seen this application? Okay. Have you ever seen this application? If yes, where? Think of it. Again, in Google search you can type anything, it actually picks up the right word and shows up. It also depends not just the minimum edit distance, also the current trend in the particular location area, but in general if you type the word, it automatically corrects the sentence. But even in PowerPoint, I am using PowerPoint, it will show the wrong sentence in the red color underlined, right. That is exactly right. So, in a word corrections in PowerPoint, this has been used. So, you have seen this everywhere. Okay, these are the basic concepts I want you to understand in NLP. Why I am talking about these concepts? I want you to use these concepts in order to create some automated grading system in a next video. Thank you.